this is Priyanshi. Our topics for today are sorting and searching. Now, what is sorting, you ask? Well, sorting is basically arranging your array in either ascending or descending order. And searching, well, if you're given a value, you have to find whether that value exists in our array or not. That's all these both topics are. And let's move on to sorting. Well, we are given an array like this, and what we want a final array to look like, and not just printing out the values, we want values to be actually moving, is what we want our array to look like this. Now, how do we go from here to there? Well, there are many different types of sorting algorithms like insertion, quick selection, bubble. But what we're going to use today is a really intuitive algorithm that's called the selection sort. And what we do in the selection sort is that first let's slide out the positions of these elements over here. So what we're going to do is we're going to take a min variable that is going to store the position of the minimum element. Okay, so for example, and at the start we're just going to assume that our this element, for example the first element, is going to be the minimum element, so its position is 0, so minimum at first becomes 0. And once we have our assumed min, then we traverse the rest of the array looking for a contradiction. Now what this contradiction might be is that when we move to this position, for example, we look, hey look, the value stored at this position is actually lesser than this value over here. So our minimum position becomes not 0 but 1. And when we move on to 2, we see, hey, this condition still uh, prevails because 2 is actually greater than 1 and not less than 1. So our assumed min still remains 1. Okay. And then when we move to 3, we see, oh, look, 0 is actually less than 1 over here. So 1 shouldn't be the lesser position value, it should rather be 3. And well, with 3, the value still remains the same. So once we have this, we are going to perform a swap. So what exactly is a swap? Well, let me clear this out for you. In a swap, what we do is we are going to exchange these two values over here. So this was actually our assumed min, and this is the min that we found out in the which should be the real min exactly. So we are going to swap these two values, and after our first iteration, our array is going to look something like this. So you can notice our array is actually already sorted, but as we are still going to have to move n minus 1 times, because you see, once we have found a min in the rest of the array, this position over here becomes fixed, and this is the array that has yet to be sorted. We then assume this to be the min and then traverse the rest of the array. And once this position becomes fixed, we have to sort out this array. So you see this continues n minus 1 times. Okay. So now that we have that, let's take a look at the code. So we are accepting the length of the array from the user and making an array out of it, filling it with random values, printing it out to take a look at what an array is. And this right here is the entire logic for a selection sort. Okay, so what happens is that we are taking the min pos, which we already discussed. We're taking two variables because we're taking I and j both, because you see we are going to traverse in the outer loop through each of these elements one by one, because we need to have an assumed min, right? And then only we can traverse the rest of the array. So this traversal is the inner loop, this assumption of the min is the outer loop. So you got it? And so once we have that, we need a temp variable to perform the swap. So we have all of that, and we're going to just breeze through our outer loop over here, and then we are going to have an assumed min position, and we are going to traverse the rest of the array looking for a contradiction. As soon as we find a contradiction, for example, the value at the min position is actually greater than some other value, we are going to change our min position to that value. And once we have traversed the entire array, what we do is perform a swap right over here. Now, the swap is going to be between our assumed min position, which is I is our assumed min position, and min pos, which is now storing the real mean. And now this can be I also, but to generalize it, we have just kept it min pos like that. Okay. So once we are done with that, we just print out our sorted array. Now let's take a look at the demo. So 5 is our array length. And if we do that, you can see this was our original array and this is the sorted ascending order array. Now, if we want to do this in descending order, just reverse this little sign over here and to compile this again. As you can see, this was our unsorted array and this is now a sorted array over here. Let's move on to searching. The simplest type of searching is linear searching, and suppose we have to find if this value 0 is present in this array or not. So what we do is that we move across, we traverse this array one by one element at a time, and then we make comparisons. Each of these elements are compared with our value over here. So the comparisons will look something like this: 3 equal to 3, 1 equal to, sorry, not 3, rather 0 is the value. 1 equal to 0 till we find a match. And once we find a match, we're not going to just print there and there itself. We are going to take a flag variable whose values are either 0 or 1. So we are going to initialize that flag variable with 0, and once we found a successful match inside our loop, then we are going to change that value to 1. Okay. And and also we're going to break out of it because there's no point doing any more iterations. And once we're out of the loop, then depending upon the value of the flag variable, which is either 0 or 1, we will print yes or no on whether the search is successful or not. So let's look at the code for it. Again, we are accepting the length of the array and then the value to be searched from the user. We are generating random values, storing them in our array, and then printing out that array. And this is the logic for our linear search. Again, we are initializing that flag is equal to 0. We are traversing the entire length of the array, and then we are doing element-wise comparisons with val. As soon as the condition is satisfied, we change flag to 1. We break out of there, and then if this condition is never satisfied, then this flag will remain 0. And with just the help of a ternary operator, we are printing out yes or no. Let's move on to binary search. So to perform binary search, we need an already sorted array, and this array can either be in ascending or descending order. And since we have already learned how to sort an array, we can perform binary search on literally any array. Okay, for all we have to do is first sort it. So once we have that array, all we are going to use the divide and conquer algorithm. That's the binary search algorithm. So how do we proceed? Is that we are going to divide our arrays into halves iteratively, and then we are going to discard one of those halves iteratively until we are just left with a single element. Okay. And where do we begin? Well, let's assume this is the element that has to be found. So instead of comparing with the first position, we are going to always compare with the mid position. Now, how do we find the mid position? Well, the mid position is essentially the left index plus the right index by 2. So here the left index is 0, the right index is 4, divided by 2 is 2. So this is our mid position. And comparisons only occur at the mid position. So we are going to compare 0 and 2 over here. Well, since they are not equal to each other, then we are going to make a little adjustment in our left and right positions. So what are we going to do is we're going to check if this 0 is either greater than or less than this mid value over here. If this is less than this mid value over here, we know that this part of my means that in any of the numbers after this mid position are never going to be equal to this 0. Since it's an already sorted array, it's going to be less than that in an ascending order sorted array. Okay. So all if this 0 is less than 2, then we are going to make a shift, and our the right index essentially becomes mid minus 1, because we have already checked that mid is not equal to 0. We are just going to do mid minus 1, and this is the two parts in which our array gets divided into. So we are going to discard this 3 3 over here, and then we are going to repeat the same procedure. So right is mid minus 1, or right is equal to 1, and left is still 0, so 0 plus 1 by 2 becomes 0, and at the 0th position, which is this right over here, we are going to compare our value and this. If there's a match, then great, we have found the value. But if there's not, well, we know that there's no other position in the array where we can find our value. And yes, we have found our value, and so we will print out yes. That's exactly what we're going to do. Let's see the code for this, and maybe this become a little bit more clear. So we are going to accept same the length of the array, the value. We are going to then insert the random values. We are going to perform, sorry, we are going to perform selection sort on it, and then we're going to print out the sorted array. So let's see the logic for binary search. And this right here, this is all we have to do, okay, for binary search. And just like we had before, we took a flag so that we know that we have found the element or not. And then we have a left index, a right index, which is equal to len minus 1, and a mid position. And till when should this entire iterative process should continue? Well, till our left position is lesser than or equal to our right position. Okay, but as soon as a left index gets bigger than a right index, well, we know we have completed all of, we have seen all of the position in our array. Okay. So a mid position, just like a formula, we find out the mid position, we check if the val is equal to the value stored at that mid position. If yes, then we break out of that and the flag is 1. If not, and the value is actually less than it, then we change the right index value. And if not, we change the left index value. Well, the advantage of binary search is that we didn't have to look through all of the elements. But well, with the 0 example, all we had to look in this array was the value 2 and the value 0, and we found 0. Well, let's assume that the value that we have to find is not actually present in the array, for example, minus 1. Well, then with when we compare with 2 and we don't find minus 1 to be equal to 2, we shift our left, sorry, our left remains 0, our right becomes 1, and then we compare with 0, and then we don't find it, our left becomes 0, right becomes 0, and then, well, 0 is not still equal to minus 1, so our left is still 0, our right becomes minus 1. As you can see, our left is actually greater than the right, and that's where our while loop will interfere, the while loop that we had over here. This will interfere and it will bring us out of the loop. The flag is still equal to 0, and therefore we have confirmed that that value is not present in our loop. Sorry, that value is not present in our array. Let's just look at a quick demo. We have a length of 5 and the value 0 is to be found, and yes, this was a sorted array. We have found that value. But what about the value minus 1, which is not present? Well, it gives out the answer no. Well, this is a really beautiful algorithm if you look carefully at the code, and I hope you learned something new today. Thank you.